Imagine navigating a 100,000-ton vessel blindly through a dense fog bank. You are driving a floating skyscraper with minimal visibility and miles of stopping distance. Now, place that floating skyscraper into a crowded global shipping lane. These lanes act as massive intersections, constantly shared by crews representing dozens of different nations and entirely different cultures. When two ships are on a collision course, the crews need to arrange a safe passing. But an attempt to coordinate over the radio can easily dissolve into a chaotic wall of static and conflicting native languages. Out on the open water, a misunderstood word leads directly to multi-million-dollar disasters. To operate safely, the maritime industry had to completely re-engineer the way humans speak to each other, building a strict, layered defense system against both physical limits and cultural slang. The maritime industry treats communication as a high-precision survival tool, engineered specifically to prevent physical disaster. Before voice transmissions existed, sailors relied entirely on line-of-sight visual communication to bridge the gap across the water. They hoisted specific sequences of brightly colored flags, a signaling method that is still legally mandated today. As a modern ship approaches a harbor, the crew might hoist the yellow and blue Gulf flag, which visually telegraphs to everyone around them, "I require a local harbor pilot." The moment that local navigation expert safely climbs aboard, the crew swaps it for the red and white hotel flag, confirming to surrounding traffic that the pilot has actively taken the helm. Flags work perfectly in clear daylight, but reaching ships over the horizon requires a technological leap into voice transmission, specifically very high-frequency radio, or VHF. But marine VHF comes with a severe physical constraint known as simplex communication. This means there is only one active frequency. If two captains press their transmitter buttons at the exact same moment, the actual radio signals collide and cancel each other out in a chaotic burst of static. Using the word "over" serves as a critical operational signal, announcing that you have released your transmitter button, so the single-file channel is finally clear for a reply. To bypass this limitation and allow for simultaneous back-and-forth conversation, engineers introduced duplex channels. These split the connection across two completely separate frequencies, allowing one station to transmit on frequency A while receiving on frequency B. However, in American waters, the government sold off many of these secondary duplex frequencies to commercial railways. To accommodate this, marine radios feature a specific USA mode that physically locks out those sold-off frequencies, preventing ships from illegally broadcasting over land-based systems. Yet, standardizing radio hardware and mastering frequency constraints only solves the mechanical physics of communication. A perfectly clear transmission still fails if the person receiving it misinterprets your words. A phrase casually translated from French or Spanish might mean absolutely nothing to an officer who learned English from a textbook in Asia. For a solution, the shipping industry actually looked upward. Because early commercial aviation heavily involved English-speaking nations, civil air traffic controllers quickly established English as their universal operational language. Following aviation's lead, the International Maritime Organization officially declared English the mandated language of the sea in the late 1980s. But conversational English is highly ambiguous. To fix this, they developed Standard Maritime Communication Phrases, or SMCP, a ridging framework explicitly designed to strip all slang from the language. Take the word should. To a non-native speaker, should is a terrifyingly vague word. Is it an order, a suggestion, a warning? SMCP eliminates the word entirely, replacing it with a strict message marker at the start of the sentence. The transmission becomes an absolute legal statement. Advice: take the deep water route. Oddly enough, native English speakers are notoriously the worst offenders. Because they are naturally comfortable with the language, they constantly slip back into casual idioms, completely unaware that their everyday vocabulary is confusing the foreign ships around them. Native speakers must actively suppress their instincts. Only by rigidly adhering to the strict SMCP framework can a crew guarantee their intent survives the journey across cultural boundaries. These protocols are highly effective in normal conditions, but they break down when a vessel is taking on heavy water, and sudden panic destroys an officer's ability to calmly format sentences. The internationally recognized frequency for distress is VHF channel 16. Broadcasting the word Mayday 3 times on this channel takes advantage of that strict simplex limit, instantly forcing all other regional radio traffic to a dead stop. If the ship is sinking rapidly and the main power is dead, the crew has to rely on portable, battery-powered radios they manage to grab on their way into the life raft. Operating near the water surface severely limits a handheld radio's line of sight to just a couple of miles. But if a passing ship or rescue craft manages to pick up that faint signal, they can physically triangulate the VHF transmission to pinpoint the raft's location. To address situations where verbal communication is completely impossible, modern marine radios are equipped with an automated final layer of defense, Digital Selective Calling, or DSC. DSC operates like a digital paging system. Under severe duress, a crew member can simply flip up a protective red cover and hold down a single button. It requires zero English proficiency and zero memory of SMCP rules. As this map illustrates, the radio automatically blasts a digital data burst to every single DSC station within a 30-mile radius. This triggers piercing alarms on the bridges of surrounding ships, forcefully populating their screens with the sinking vessel's unique identity code and exact GPS coordinates. DSC bypasses panic and language barriers entirely, delivering an instant, mathematically accurate cry for help before a single word is ever spoken. The ocean is a deeply hostile environment, entirely unforgiving of human error. Navigating it safely demands specific, overlapping layers of defense, hoisting sequence flags to signal visual intent, strictly structuring radio phrases to strip away ambiguity, and integrating automated digital distress signals. By meticulously standardizing exactly what crews say and exactly which frequencies they use to say it, the industry successfully cut through the noise of thousands of overlapping cultures. They engineered a system that pushes past physical limits and linguistic barriers, guaranteeing that when one ship calls out in the darkness, the rest of the world understands.